All right, so today we're talking about using triangle congruence to prove that parts of triangles are actually congruent as well. So you know that we are allowed to use the definition of congruent triangles to say, hey, if I prove that all the angles and all the corresponding sides of two triangles are congruent, they're going to be congruent. On the other hand, if we use one of the shortcuts we learned yesterday, to prove that they're congruent. Well, then after we've proved they're congruent, well, then we know that all the corresponding pieces will also be congruent. So what we need to do is say, are we going to try to prove congruency? Then cool. But sometimes once we've done that, we want to go one step further and say, yeah, look at this. Because the two triangles are congruent, yeah, that angle over there is congruent to its corresponding part of the other triangle that it's congruent to. So I kind of spelled this out saying, if you've got two congruent triangles, you can list out the sides that match. Be like, oh, CB is congruent to DE. You could list out all three sides. Like this one is congruent to this one here, and then this guy over here is congruent to over here. So you could list out all three corresponding sides that are congruent to each other. And then you could even talk about all three angles that are corresponding and also congruent. So like, oh, angle B is congruent to angle D. And then also you could say A and F. And you could say the last one would be C and E. Okay, so we could also do these guys and be like, oh yeah, DF is going to be congruent to AB. And the last one is going to be that AC is going to be congruent to EF. So if they're congruent, well, you could say one of those six things. Well, so here we go. So first, if we show that the triangles are congruent using one of these special methods below, then, we've talked about two sides in an angle or two angles in a side or three sides. Well, once we've shown it's congruent, then we can make a statement of like, oh, guess what? Because we have congruent triangles, well, then this bottom side has to match this bottom side over here. And what would be the reason? Well, the reason is we've got congruent triangles, so therefore the corresponding parts of those congruent triangles are going to be congruent to each other. Well, that's a lot of words. So here's the acronym we use to say once you've proven something to be congruent, then we can go ahead and say, hey, I'll call out the other two sides or the other two angles or whatever you want to, corresponding parts, and say, guess what? These guys are also congruent because corresponding parts in a congruent triangle between two congruent triangles are going to be congruent to each other. And so that's what we're going to do today. This is a review, are these triangles congruent? And if so, why? Okay, and so on your Delta Math today, it'll say, hey, why? And so the deal is you've got reflexive property to say this is going to be the case, but first you would say, hey, we have a right triangle, therefore we would say the hypotenuse of the legs, one of the legs is going to be congruent to the other leg. So hypotenuse leg, because you have a right triangle. Let's just say AL, sorry, hypotenuse leg. And then also in this one, you've got angle, angle, side. These are vertical angles, so angle, angle, side. So yes, those would be congruent. These are angle, 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 so that would be no. And the last one is angle, side, angle, and that would be yes. Okay, it's a valid proof. So in the back, we go through and say, let's try these things. And so in class, I ask students to, go through them and try them. If you've got two angles that are congruent, we've got K and M, mark them. Okay, these are congruent to each other. That's given. Okay, JL bisects angle KLM. Well, KLM is a big angle, so if you cut something in half, you've got two little pieces. You're going to cut a cell in half, because it's doing mitosis or meiosis, which are one of those things. And it takes the one original and becomes two smaller cells. And so in this angle, we've got an angle and it's bisected, which means it's cut into two congruent pieces. So this congruent piece and this congruent angle as well. So if this bisects this angle, well, that was given. Well, what does it become? Well, two pieces that are going to be congruent to each other. So your angle KLJ is congruent to angle JLM. Okay, so those two angles will be congruent to each other. Now we've got two angles that match within the two triangles. We're trying to prove that these two triangles match each other, that they're congruent. We're out of givens. So what else can we see from the diagram? Well, we see this right here. And this says that I can't tell what it says, JL segment is congruent to JL. Why? because of the reflexive property. Okay, so why are these congruent? Definition of congruent or bisectors, angle bisectors. Okay, so the angle bisector, so it chops into two congruent pieces. So now we've got two angles that are congruent, K and M. We've got two angles over here, and then we've got a side. So angle, angle, side. So we can write these two triangles are congruent. Why? Because of angle, angle, side. And you could write more, but you can also just stop there and say, hey, the angle, angle, side rule. And it's a congruency postulate. And so the next one is going to be angle N and P are right angles. So we can label that. N and P are right angles. And then it says MP right here matches this right here. And those are both given. Okay, so the first one's a given. It says, hey, that means that this is a right triangle. Okay, that's a definition of a right triangle. You got a right angle within a triangle, you know it's a right triangle. So we're on our way to probably using the hypotenuse leg, aren't we? You know, so first you define it to be a right triangle, but then you say, hey, it says MP and ON are congruent. Okay, they're congruent by given. And we mark those. So we've got, and then we can do the hypotenuse by saying, hey, guess what? MO is congruent to itself by the reflexive property of congruence. And now we can say, hey, guess what? The two triangles are congruent, put it in the same relative order. The order does matter. And that means that by what? By hypotenuse leg. Now we're done with proving the triangles are congruent. We showed that those two triangles are congruent. We want to take it one step further. If we know the triangles are congruent, what else do we know? Well, we know the corresponding parts will be congruent to each other. So they're saying, does that mean that MN matches OP? The answer is, of course it does. So you're right. MN is congruent to OP. Why? Because the corresponding parts of congruent triangles will be congruent to each other. And so because we proved the triangle's congruent, well, even though we only talked about, you know, a couple of the parts, we know all the corresponding parts will be congruent to each other. Okay, the last proof for today has some common factors that happen within proofs. It says these two lines are parallel to each other, okay, and that is given. And so JK is going to be parallel to LM. And then it says, hey, angle 2 and 4 are what? And they're alternate interior angles by definition of alternate interior. So that means that 2 and 4 are congruent. Why? The alternate interior angle theorem. Okay. Alternate interior angle theorem. That was fun. Try it again. So these two lines are also parallel. So that means that angle 1 and angle 3 are also alternate interior. Why? Definition. Okay, so this is given of alternate interior. Okay, and then that means that angle 1 and 3 are congruent. Why? Alternate interior angles theorem. And then because the reflexive property, we can call JM congruent to itself. Okay, and then that means by, what do we know? We have two angles that match. We have two other angles that match. And then we have a side, so angle, side, angle. So they're congruent by angle, side, angle. Label what you find as you do it. And then as a result, they ask you about parts. So if those two triangles are congruent by angle, side, angle, then that means their corresponding parts are also congruent. So that means that KM, which is here, is going to be congruent to down here because corresponding parts of congruent triangles are congruent.